So hopefully you just finished the Desmos that kind of introduces you to some ideas about functions or reintroduces the idea about functions and the idea of limits, where when we're looking at this here, this graph, we're going to talk about a couple different points here, but the Desmos that you should have dealt with kind of went through and said, hey, like what is g of, -2? Meaning like if I plugged in the x value of -2, it spits out a y value, which is in this case 0. So it's going to help us with limits, but limits don't necessarily have anything to do with the actual point itself at, let's say, -2 here. So I want to start by focusing on this first one. The limit is represented like this that I have in the red box. It says LIM for limit as x goes towards -2. So I'm looking at both sides. So I see on my graph here, that's where x is equal to -2. I see on the left side, it is coming up towards -2 here. And also on the right side of that point, it is going towards negative here, or it approaches from the left side and the right side. It's looking for what y value is our function approaching as x goes towards -2. So in this one here, it's just going to be 0 because we see the left and the right side arrow are both pointing towards the y value of 0. Same thing with -1 here. If I plug in an x value of -1, I see the left side is coming up and pointing at that point. The right side is now coming down and pointing at that point. And both the left and the right side are coming in and pointing at the y value of 3. So the idea of a limit is we're really looking at both sides of this x value. As we approach that value, what's the y value? So this next one is where it gets a little bit trickier here, where it says when we approach 0, because when we approach 0, again, if I'm drawing these arrows from the left side, it looks like it's pointing at 4. If I come from the right side, it's looking like it's pointing at 4. So my limit as x approaches 0 is 4. The reason that this can get confusing is because if I were to actually say, hey, what is, f, or in this case, g of 0, like if I plug in 0, my output is going to be 1. So g of 0 in this situation is not the same as the limit, because the limit, looking at my graph here, it approaches from the left and the right towards 4. And so that's what my limit is all about. It's all about how is the graph approaching this x value. When we talk about the next one, it kind of gets even more tricky because it's saying, hey, what's the limit as x approaches 1? And when I go from the left side, it's approaching the y value of 3. But if I look at the approaching from the right side, and it's approaching the y value of 2. You cannot have a limit that approaches two different values. When that happens, we end up saying that the limit does not exist. So if you see DNE, it means does not exist. So in this situation, the limit as x goes towards 1 doesn't exist. But in this last one here, as the limit approaches, x approaches 2, we see that it's approaching the same y value here on both sides. And so the limit as x goes towards 2 is 1. So again, the limit has to do with how does my graph approach this x value, and is it going towards the same y value? If it goes towards the same y value, great, that's our limit. So like the first one, they both point towards 0. The second one, they both point towards 3. The third one, they both point towards 4. Then the fourth one here, they do not both point at the same y value, so we say that it doesn't exist. And the last one points at 1. So what's important to understand is that the filled in part of the circles here doesn't actually really matter. All I care about for the limits is what's happening on either side, and are they pointing towards the same y value. So the graph is pretty straightforward and easy to kind of see this. It's fairly easy to see that like this one doesn't exist because it goes towards two different values, right? But When we look at data or like a table, that's when it gets a little bit trickier to see. So if we see something like this one here, I'm looking at a bunch of x values and a bunch of y values. The limit that I'm looking for is as x goes towards -1, the y value is going to go towards what? So the limit is what? And when I look at this data here, what I see when I talk about like the left and the right side on the graph, what I should notice is that this is really talking about the left side, sorry, the left side of this, because -1, as I keep going down in this table, it's getting closer and closer and closer to the x value of -1. Whereas this part of the table is the right side. And as I get closer, so as it's going closer and closer and closer to -1, I'm looking for what is the y value. So really in this situation here, I'm saying like, hey, I want to know what's happening on this graph at x equals -1. So what would the y value, what would we guess or estimate that the y value might be given this table? And if we kind of look at the trend here, looks like this here is getting closer and closer and closer to 3. If I look at this side here, same idea. As we go kind of closer to that x value of -1, the y value is getting closer to 3. So if I were to write my limit here, I would say the limit as x approaches -1, f of x equals 3. Same idea for this next one here. If I'm looking at this, I'm really looking for the limit as x goes towards -2. That x value kind of would fit in right here in the data, and I'm looking for what are those points really, really close to or approaching from the left and the right side. In this situation here, it looks like it's getting closer and closer and closer to 4. So my limit would be equal to 4. Again, we're just looking at, are both the left and the right side approaching the same value? So if this case here, was, if all these values were like 5, that would mean like that one side was approaching 5 and the other side was approaching 4. And that one we would say that the limit doesn't exist. But because both sides of this graph, both sides of this function would be pointing towards the same y value, we say the limit is 4. So there's 3 different ways we might look and try and figure out what a limit looks like. The first one is a graph. And the graph is fairly straightforward, right? We look at, if we're saying, hey, what's the limit as x goes towards +2 for f of x? In the graph, it's really simple. I find the x value of 2. I find where is that on the graph. And I look, does the left and the right side of it point towards the same y value? If it does, then the limit is just that y value. Same idea with the data here. If I'm looking for the limit as x goes towards 2, I see, okay, hey, all the x values that are approaching it on the left side and all the values that are approaching it from the right side, are they going towards the same y value? In this case, it looks like they are because this one is increasing and getting closer and closer to 4. This is kind of decreasing if I go from right to left, but both of them are kind of going towards the same value of 4. So again, kind of easy to see with the graph or the data. The goal will be next week sometime is to start finding the limit of an equation. So if I say the limit as x approaches 2 of this equation 3x minus 2. And next week we'll go through how that works. Today I really want to focus on you looking at a graph and being able to tell what the limit is. And I just want to make sure that you understand that on a graph, like if we're looking at some sort of graph and we see this kind of like break here where we're looking at this x value, let's say that this x value here is 5. I should be able to, just by looking at this, automatically say I know that the limit does not exist as x approaches 5. Because when we look at the left side, it's approaching one value, and from the right side, it's approaching a second different value. Whereas if I was looking at this side here, let's say that this is an x value of 1, I know that the limit does exist at whatever y value that point is at, because it looks like both the left side and the right side are approaching that value. And again, if I had something that like this where I had kind of this jump point, I have a little hole here where it's an open circle, and then I have like a filled in hole here that's not connected. That doesn't change the limit because still the left side and the right side are pointing towards the same y value. So I'm really looking for what is that y value, and that would be my limit at that x value. So next up, after you're finished with this, you should be hopping into the book for number 14 through 17 in chapter 7. And once you finish that, you should be able to get a worksheet that you can kind of go through. And I will have the answer key posted so that you can double check those things. So good luck. Send me an email if you have any questions, or we will catch up on how this is done on Friday.